Hello, everybody. Today we're gonna do the urinary system, and one of the main thing it would be the kidneys. Okay, so what do kidneys do? Um, Kidneys. One of the main thing about the kidney, it will, um, as it says here, it will clean the blood, getting rid of the waste, regulate your pH, regulate blood pressure, the number of red blood cells. So it it checks the concentration of the red blood cells and producing vitamin D, which is it will convert the calcidiol to calcitriol, which is the active form of vitamin D. So if you look at urine, some of the physical characteristics, okay, and if we do a urine analysis, okay, you should not have any blood, okay, no glucose, ketone, nitrite, and just trace amount of all these other things. Color should be pale or yellow, should be odorless, okay, pH should be around here. Yes, there's a specialized capillaries, okay, that we're going to learn about. It's called glomeruli, okay, and what it does, it will filter blood on the size, and large stuff stays in the blood. So it will filter the blood, as we're going to look through it in a minute. So your glomeruli will filter about 200 liters per day of your blood, okay, and it will only excrete about 2 liters to become urine, okay. So here's what the color of the urine should be, okay. Okay, if you're well hydrated, it's in this color. You dehydrate it, and then of course this is extreme, okay. If you have little or no urine, okay, it's called oliguria, okay. No urine at all is anuria, and excessive urine is polyuria. Okay, of course this is a medical emergency if you have no urine, because the toxic will build up, and then you could die from there, okay. Some fruits and vegetables could affect the pH and the smell, okay, as some of you have eaten maybe asparagus, okay, and that will show up almost immediately, okay. No cells should be in the urine, no protein, no blood, no ketones, okay, remember that. Of course, if you're on your menses, you might see some blood, but it's not directly from the kidneys itself, okay. If you have some blood, it might be indication of maybe a kidney stone or a cancer, okay. Or if you have sugar in there, you might have glucose, right? Glucose, you might have diabetes, okay. So let's look at the gross anatomy of the how urine is transported. Of course, the kidneys are up here, okay. Then the urine is produced and then is collected through the ureter, okay, and then it's collected in the bladder, okay, and it comes out through the urethra, okay. Same in the female, okay. The ureter, the bladder, okay, ureter, and then the urethra, okay. But sometimes when the female is pregnant, okay, so this will be pressing against it, and they'll have to go to the bathroom more often. Same as the male, if the prostate is enlarged and it is pressing on the bladder, you will have frequent urination. Also, as you remember, in AP1, the cells for the urinary bladder, it's a transitional epithelium, so it's very stretchable. So it will stretch, and when the stretch reflex will will start the parasympathetic stimulation, and then you will start to begin to feel like you want to pee, okay. That's the transitional epithelium. So internal and external urethra, okay, which is on the external urethra is on the outside, okay. It is voluntary, so when you need to pee, you can hold it, okay. even in some quadriplegic patients, they lose their external voluntary control, but they might still have the sphincter working. So in that case, they might need a catheter for them to go pee. So when you need to go pee, there's a term for that. It's called micturition. It's the same thing. Okay. And we talked about, so the female, of course, is shorter. Okay, that's why there's more UTI. Okay, and the male is longer, and it's divided into 4 sections. So we're going to learn this when we do the male reproductive organs. So here's the bladder. Okay, what is that term? There it is, micturition. When you need to pee, that is the reflex for urinate, for when you want to urinate. Okay, so here are the ureters. Ureters connected to the kidneys. Okay, when the urine is made, it goes to the ureter, fill up the bladder, and then it will exit through the urethra. Okay, again, this is the transitional epithelium. Okay, which is very stretchable. Similar to the male and female, so the urethra is posterior in the female. The ureters is posterior and place pressure during pregnancy. It's a highly distendable organ, so it's very stretchy. Surrounded by transitional epithelium. Micturition reflex is when you want to pee. Okay, it's a mixture of voluntary, involuntary, and voluntary action involving the internal and external urethral sphincter. So a sphincter is, it's a muscle that can close and open. Okay, the stretch receptor comes from the sacral region, the parasympathetic. Okay, direct contraction and distension and relaxation of the internal sphincter. Okay, so when it's full, the parasympathetic branch will cause it to relax. Okay, but then you're gonna hold it. Okay, so that's your external voluntary system. So then after it's parasympathetic is sending signal to you, somatic motor neuron will carry impulses to the external sphincter, which will relax or contract. If you're gonna go pee, then it will relax. If you need to hold it, then it will contract. Okay. So ureter. The ureters again are the tubes. The tubes going to fill up the bladder. Each one's about 30 centimeters long, extend downward. Okay. Runs parallel to the vertebral column and then join the urinary bladder, pelvic cavity. Okay, so again, it's a tube. So it has a lumen. It's got muscles. Okay. There's inner mucosa. Okay, there's a thick muscularis layer. And then connective tissue, collagen, and fat. And what about the kidney? Oh, I forgot to tell you. Now, because it is a muscularis, because there's muscle, okay, urine don't just fall down, okay, from the kidneys. It doesn't just fall down to the bladder. It will move with peristalsis. So it's squeezing, and the urine will be squeezed through the, collected in the bladder. So the kidneys, it regulates blood. So the kidneys will receive 25% of the cardiac output, okay, at rest. Only 1% of the body mass. So it's well protected. Okay. The size of a fist. If you look at the picture, okay, the left kidney is slightly higher than the right kidney. Okay. It's covered by a dense capsule. So if you ever had a bean, okay, it's got a little capsule, a shell on there. Okay, dense capsule to protect, surrounded by fat, and anchored to the body cavity through renal fascia. superior to the kidneys, so on top of the kidney, right there, sitting in a triangular shape, would be your adrenal gland. And here's what the inside of the kidney look like if you cut it open. Okay, so here's that cortex on the outside, protecting it. Okay, outer region. Okay, the medulla. So there's cortex and the medullary part. Medulla into the pyramids. Okay, so you can see these. These are called pyramids. Okay, so this whole thing outside will be the outside, the cortex. So if you look at the pyramids, okay, the pointy part is pointing downward and it's going to come together and it becomes something called a minor calyx. Minor calyx. Then later on, all the minor calyxes, okay, will come together and become a major calyx. Major calyx. And even further down will become the renal pelvis. Okay. And later on, it will be collected into the ureter. Okay. So we already saw the ureter. Ureter will then squeeze everything down into your bladder. Okay. So again, the cortex, the pyramids, okay, minor calyx, major calyx, renal pelvis, and down to the ureter. There's renal vein, okay, the nerves, and then the arteries. Column framework. Renal pelvis, expansion of the ureter as major calyx comes together. So the major calyx come together to that. Renal sinus, hollow chamber through which vessels, ureter, and nerve can pass through. And the renal papillae, collecting duct, converges and project into the minor calyx. Okay, so the renal papillae will be here and collect everything into the minor calyx. So here, this picture we'll see a lot, okay? So let's look through it and then go from there. Okay, so here's the kidney, okay? The outside right here in the cortex, okay? There are tons, millions and thousands of these, okay? These are called a nephron, okay? This whole thing is called nephron. Nephron is a functional unit of the kidney, okay? So let me see if there's another picture of this, okay? Well, anyway, here it is, nephron, okay? Nephron, a functional unit. It cleans the blood, okay? Balance the constituent and return everything, a lot of things back to the circulation. So one of the things to remember here is called the glomerulus, okay? Glomerulus, okay? Glomerulus. And the outside of it, there's a capsule surrounding it. It's called the Bowman capsule. Bowman. Let me see if there's a spelling for you. Okay, Bowman capsule, okay? So there are arteries and veins going into, and we're going to see it in a minute, okay? And then we need to know all these, proximal convoluted tubule and loop of Henle, and then distal convoluted tubule. But right now we will focus on the glomerulus, okay? You see a lot of blood. So in the glomerulus, you'll see afferent arterial, which means they're going in, okay? And then efferent, they're exiting now, okay? Exiting. So here's where a lot of things are filtered. So where are the nephrons? Okay, they're mostly on the cortex, so they just on the outside right here. Lots of little nephrons, okay? Again, the outside of this is called the glomerular capsule or the Bowman's capsule. Which is part of the renal corpuscle, is in the cortex. Okay, so then these parts will be extended downward. Also, there is the proximal